Ladies, gentlemen, good afternoon, and welcome to a session on developing more intelligent applications by means of data mining. My name is Rafał Lukawiecki. As you can see from the slide, I don't work for Microsoft. I work for a small consulting company based in the UK called Project Botticelli Limited, and I very much welcome any questions you may have during and after the session. If you haven't had a chance to catch me around here or perhaps somewhere in the exhibition hall next to the business intelligence stands, do send a question by email. I always respond to all of the emails. It takes me some time, so if your question is urgent, mark it as such and I'll attend to it straight away. Otherwise, I normally respond about 3 weeks or so after I get emails, typically at the latest. So, why am I talking about data mining? Some of you may have met me before, and I'm always glad to see the same faces coming back to some of my presentations. And some of you who have met me before know that the key area of my specialization is in security, in particular in cryptography. Well, let me give you a little bit of a background to that. If you want to deal with cryptography and security, you kind of have to have some understanding of statistics and some, perhaps, working knowledge of probability. Guess what? In order to be able to deal with data mining, you need to have some understanding of statistics and reasonably good understanding of probability. In fact, I would like to claim that data mining and cryptography is pretty much the same thing. It's just the other way around. Cryptography hides data very well, and data mining finds information that's hidden. Amazingly, the algorithms that I use to do one and the other are very similar. So I am really recycling the knowledge I already have when I deal with data mining, and I could introduce data mining as cryptography to the power of -1 if you wanted to, but that obviously wouldn't make much sense. So yes, data mining is kind of new for me. When I say new, I've been dabbling with it only for about the last 2.5, 3 years or so, and it's only now that I have a chance to talk about what I have discovered and found and share with you. And I honestly believe that the stuff I've got to show you here is like one of the coolest things you're going to see at TechEd. Yes, it's unusual, it is strange, it requires a bit of perhaps dry thinking connected to statistics and probability, which isn't the most exciting thing in the world, but honestly, it is one of the coolest things. I think if you use what I'm going to show you here in your applications, you are going to be one of the first people on this planet to start employing the power of almost artificial intelligence to make your applications certainly much more intelligent. So I'm excited about it. Hopefully you will be too. Let me get on with the session and tell you what I've got prepared for you. This session obviously is designed to make it possible for you to create more intelligent applications by means of data mining. To do that, I want to achieve 4 objectives. First of all, I want to introduce data mining using as little theory as I can. I want to make it practical. Secondly, I need to drill into some of the data mining concepts that are necessary for you as a developer. Sadly for me, but perhaps good for you, considering that it's 5:30 in the afternoon, I am not going to go here into a debate of every data mining algorithm that exists. I actually would love to have a session on that, and if you think it's one that should be here at next year's TechEd, please put it in your comments, and I will try to convince the organizers that I should have 75 minutes to talk about algorithms, but this time they told me no, so I have to be more practical. So my overview of the algorithms by nature will be very limited. Actually, I'll have to constrain myself in about 3 slides. Originally, I had about 50 just on algorithms. And I want to give you an example. The example, yes, it's a demo, living demo, not a PowerPoint demo, a real demo with all the drama, will it work, will it not work, that you will enjoy, no doubt. A demo that you can download yourself also from www.sqlserverdataMining.com. That URL is at the end of my presentation, in case you don't want to write it down now. The demo that you can execute yourself, it's a little dirty, it's a little simple, but it really demonstrates the concept extremely well. I'm planning to spend hopefully 10 to 15 minutes just showing the demo to make sure the idea really sinks in for you. Right, so that's the plan, and to those of you who are still thinking, why do we need to use data mining, here is the key 3 reasons that I have found out. One, and I'm sure you will agree with me, your my client software has to deal with an ever-increasing number of unpredictable conditions. We are tired, sick and tired of writing exception handlers. We want to get on with writing the code that really does something useful, rather than, as it is in most of today's software, twice as many lines of code at least for error control and exception handling. After all, you became a developer, not an exception handler. So yes, I feel it, and you know what I'm talking about. We are sick and tired of that. By the way, if you love writing exception handlers, that's great. There's more job and work for you probably than for the normal developer nowadays. You probably should consider becoming a tester, though. Of course, we want to make our applications more intelligent, not just because it's cool to say my application is intelligent, but actually because they deliver value to the customer. They do what the customer wants, and they do it sometimes in ways that will even surprise your customer. I'll give you some examples of that. Customers really start to feel that your application is unusual, but in a good way. I'm not talking about clip that, you know, kind of pops up when you start typing a letter and asks you whether you are, you know, just starting to write some kind of a suicide note or whatever, and would help you along the way. Something about really useful stuff. Of course, as you have guessed, because you came to this session, you need to use data mining for this purpose. Well, you could use other techniques. Notably, you could use some artificial intelligence concepts, but those don't work yet very well. They might work in the future. Today, data mining is the closest, lowest hanging fruit you can get to that. So, what's the essence of data mining for building intelligent applications? Let me introduce the main hero of this presentation. Data mining is a set of technologies for predictive analysis, or for analysis of data so you can find patterns which are hiding in it. This technology, as you already have heard me mention, use a combination of statistics and probability, but that's not enough. Statistics and probability, which are old and well understood, plus modern, very recent, sometimes coming from the world of artificial intelligence, database techniques. If I were to give to you a simple explanation why we cannot just use statistics and probability, then it will go like this. Your database, or databases, or warehouse contains perhaps millions, or millions, or maybe trillions or billions of records. For any statistical probabilistic method to work, you have to load them all into memory at the same time to do a computation. And that's, of course, where we cannot do it. Of course, the database people have coped with this problem all the time. They have huge databases which are more than able to handle such numbers by cleverly knowing what matters, what is significant, and of course loading into memory only the things that are relevant. So how about, let's combine a bit of Kimberly Tripp, who knows everything about databases, with a little bit of perhaps myself, who knows something about statistics and probability, and the child of that marriage happens to be data mining, which can do the impossible task of processing enormous amount of data with a statistical probabilistic correctness. That is the dirty way to understand what DM really does for you. It's new, it's young, it's growing, it is, to me at least, one of the most important technologies on the market right now. Those of you who know me for my security talks probably know that I am still enthusiastic about security. I must tell you that as big as security has been for us in the past 10 years, I believe data mining will be as big, if not bigger, for the next 10 years. You are at the beginning of something really, truly sexy. So, data mining enables something called predictive analysis. Now, I'm going to go through this marketing-like slide very quickly, only to show you a certain gap and a percentage. Canned reporting, everybody knows how to do it. Ad hoc reporting, where you just write some select queries, or you use reporting engines, crystal reports, whatever you do. And then we get, of course, to more advanced forms of analysis, such as OLAP, and at the top, data mining. The difference between canned reporting and data mining is primarily in how discoverable versus presentational it is, as well as how proactive versus passive it is. Yes, data mining is proactive and discoverable, meaning that it leads itself to research. It leads itself to you sitting in front of the computer and having a great time mining data for half an hour, 6 hours, 2 days, and then finding gold in the maze of information that's hidden somewhere in your data warehouse. There is something amazing, though. To bridge the gap between OLAP and data mining, we need to solve a very difficult problem of both how to make it accessible to people, how to make it work, be relevant, and reliable, of course, efficient, effective, etc. It turns out that 63% of users of any type of reporting don't know how to bridge that gap. For 63% of reporting users, it is not possible today to bridge the gap easily from OLAP to data mining and cover the space of predictive analysis. The reason they cannot do it is because perhaps technology is new, but also because they need you, developers. You are the link between those two. And that's why I think if you get interested in this concept, you will have an awful lot of work in the future. So how does data mining form part of business intelligence? Well, DM is part of BI. BI uses DM. My session is not about BI, so I'm not going to talk about it at all after this slide, but so that you can position them against each other. Think about BI as being geared towards the end user, perhaps a business owner, perhaps a director, or maybe just a clerk in sales who needs to have, well, some intelligence about what happens to sales. DM is geared towards experts. DM is geared towards people who understand what it does. So that begs a question. Who is qualified today to be a user of data mining? Do you have to be an expert with a PhD in statistics and probability or not? I will answer this question very shortly, but not now. Typical applications and value of data mining belong probably to about 6 or 8 different areas. Let me go through them very quickly so you understand what you can do with it. Finding your most predictably profitable customer. In other words, what characteristics of a customer make them profitable? Understanding their needs. Why do they buy? Why do they not buy something from you on your client? Anticipating customer churn. Why do they leave your organization and join a competitor? What can you do to slow down the churn of your customers? You can predict your future sales. You can predict the status of your inventory in your warehouse. You can build better marketing campaign by experimenting with it. You build a campaign, you put it into your data miner, and you predict that it will fail. So you go back to the campaign and tweak it and experiment with it more until you have one that works well. And finally, from my security area, you can detect and prevent fraud. Data mining is a wonderful technology to detect so-called outliers, situations which are suspicious and very often lead to losses. However, in addition to all of that, which is classical use of data mining, that is the newest one and the one that this session will concentrate on. Building intelligent applications. Okay, maybe intelligent is asking for too much, so let's say more intelligent applications. Or there is a new term, if you haven't heard it yet, predictive programming has been used here and there. I'm neutral about it. I don't love it, I don't hate it. Time will show whether predictive programming is how we will call it. But in essence, it means making your application intelligent because it knows about patterns of behavior. Let me give you 3 canonical examples. Adaptive user interface. In other words, a user interface that knows what the customer will do next. That doesn't mean changing the interface all the time so the customer is confused. It means anticipating their needs, perhaps help, assistance, questions, values, and so on. 2, input validation. This is the lowest hanging fruit for you. How much do you love to write data validation functions? Well, they're kind of not very exciting. All of those asserts in whatever form they take. So what would you say if I told you from now on you don't need to write even 1 data validation function? Is that possible? Yes. Will it work? Yes. Is it real? Yes. Will it catch every possible case? Maybe not. However, in most cases, and that's the amazing bit, it will behave better than one which consists of hard-coded rules you invented. I know. So, business process validation is the third one. This is one of my favorites, but not the easiest one to do straight away. Still possible. I'll give you an example. You are writing an application for web sales, and people buy things, put it in a basket, they pay for it, shipping address is entered, ship, and they sit back and they wait for the goods. The goods never arrive. Why didn't my shopping arrive? I've entered everything okay. The site verified my address and said it's good. What's the problem? Oh, the problem is that this company ships to an address in Ireland by sending goods first to the north of France, and then, from then on, it uses different providers to send it on to Ireland. Those providers differ in quality. Some of them are good, some of them are bad. However, whenever you specify an address in Dublin, it always uses Transcontinent Express, which always delivers the goods. However, if you ship them not to Dublin, but outside of Dublin, well, the companies work differently, and typically they don't ship unless you specify your mobile phone number so the driver can call you and ask you where you are, because there are no postcodes or street numbers in Ireland. Okay, encode that as a rule for an international website that sells. Forget it, we just will not sell to Ireland. Right, that's one option. Trust me, I've been too many times in that case. I live in Ireland nowadays. I moved there recently. Okay, the other option, do nothing. Lose the packets, and the Irish customers get infuriated. Is that good? Probably not. The third case, you don't know why it fails, but you know what happened in the past. You have track record of successes and failures. Mine it. Once you've mined it, there's a pattern. You don't understand the pattern, who cares? Your application will use it to predict success or failure of a transaction. I enter my address, the address is good, everything is fine. The application takes this as a case, shoves it into the data mining engine, and the data mining engine says, And perhaps you display a message. Dear customer, your transaction will fail. Okay. We don't want perhaps to do that. So what do? The first and simplest thing you do at that point is you just highlight it to a manager, whoever is the supervisor of sales on the day. You basically flag the case and you tell them, there is a probability of 67% this will fail, and they can analyze why. Or if you are good, and at the end of my session you will be good enough for that, you actually tell the customer, dear customer, although it is not necessary, we can significantly increase the speed of delivery if you provide us your mobile telephone number. Because the data mining model will know that that's what changes the probability from 67% of failure to only 5% of failure. You have never coded for that. You have never even thought about it. It came from the data mining model. That's it. That is case number 3, business process validation. I've seen it, I've done it, I still have shivers on my skin when I talk about it. It works like magic, literally, and you will know how to do it at the end of this session. So let me get on. What's so special about it all? What's so special about that? The special thing is that your application's behavior evolves. Today it succeeds, tomorrow it fails. But the data mining model will evolve with your application. Basically, you are creating a feedback loop. The data mining engine mines your log. So the application has logs. Every application has a log, many logs, click logs, whatever, sales logs, transaction logs, whatever it is. You throw any data that's relevant from the log at it automatically. So when the application detects a problem, it obviously says that will fail. So we change our behavior. We add the mobile phone number. As a result, that transaction succeeds. because it succeeds. It is now in the log of successes. The model evolves, and it strengthens the correlation between the telephone number and success of shipping to Ireland. Can you see how your application learns as a result? The whole trick is that the data mining model is not static, but it evolves with your application. So what if something changes? What if suddenly we hire a very unreliable company to send goods from northern France to Ireland? Suddenly we have failures, of course. And maybe after 5, 10 transactions, your data mining model discovers that. And suddenly your data mining model flags that every shipment to Ireland fails, no matter what you do. And of course, the salesperson knows immediately. That creates an application with variable logic, a dynamically changing logic of success. I think that's pretty cool and pretty unusual. In the past, I'll be honest with you, if you wanted to use data mining, you had to be a statistician with a PhD, probably wearing a white coat. Yes, Microsoft has a lot of competitors in the space of data mining, and some of those companies have really good products. Some of these companies have products which certainly have more depth and perhaps even more expertise in data mining than Microsoft. But there is one big differentiator between Microsoft for data mining and the rest of the world. Microsoft took the unusual step of making the whole data mining thing work for developers. That's the key. They decided that they could compete with the PhD statisticians, but they don't want to. Instead, they have identified that you are the group of people who would like to use data mining, but you haven't traditionally in the past. So every API, everything in SQL Server 2005 and 2008 analysis services is designed with you in mind. You are at the heart. All of the competitors' products are designed for those PhDs. Okay, it will change in the next few years. But the answer to what is at present the focus of, the user focus of data mining on the Microsoft side, well, that's you. So, on 2 slides, what's in 2005 and what's in 2008? In 2005, we have a number of interesting technologies for data mining. Of course, we have all of the algorithms I mentioned briefly at the beginning. However, we have also a fabulous API for you called DMX. DMX is data mining extensions, and OLEDB for data mining, by means of which you use the analysis services just like another database connection. There's also XML for analysis and .NET Framework support in various levels. In this presentation, I will concentrate on DMX because it's the simplest, easiest, and most powerful. As far as interoperability with Microsoft competitors is concerned, Microsoft fully supports PMML, predictive model markup language, by means of which you can export and import your models. So if you have a PhD statistician who has a model, you don't need to build one, just import their model by means of PMML, and you can still use it in your application immediately. In SQL Server 2008, Microsoft made few changes to data mining, but some of them are very worthwhile mentioning now. First and foremost, they made it more convenient. The mining structures that you work with in Katmai, so in SQL Server 2008, are easier to prepare and test because you don't need to split your data into training and testing data. You can just have the whole data set and shove it into the mining model by designating a percentage for training and a percentage for testing. There's also a few interesting things that allow you to use incompatible models simultaneously. It doesn't make sense, perhaps, but it is very convenient. There are also some changes to the algorithms. Most important change is a huge improvement by means of combining the best of the ARIMA and ARTXP algorithms. ARIMA is autoregressive integrated moving average. It is a very standardized statistical mechanism for predicting long-term behavior of time-based data, such as I sold €1 worth of goods today, €5 on the next day, €10 on the day after. How many euros will I sell on day number 4? Well, you can guess perhaps 15. Well, that would be predicted by ARTXP, which is for short-term prediction. ARIMA will predict what you will sell in 5 years' time from now. And marrying the best of the both is something that SQL 2008 has done well. And also for you as a developer, there are some new interesting redistributable visualizers for data mining models if you are interested. Enough introductions. At this point, I want to tell you how would you use data mining to build an intelligent application. In this section, I will talk about the process, correct and incorrect, a few words about DMX, a few words about the steps to build an application. But after that, I will actually show you the code examples, step by step, how we build the model, and only then I will do the demo. So I'll explain things before the demo so you understand the demo better. So, first of all, the data mining process that all of you will follow, no doubt, starts with creating the data mining model. You define the columns, you choose the algorithm, but the model itself is still empty. It has no patterns. So the next thing you need to do is to put patterns into it, which is done by means of using training data and the data mining engine. The training data is fed into the engine, and that creates structures known as data mining structures, which contain those patterns that you discovered, like shipments to Ireland fail if there is no mobile phone number. You may be thinking now, what is training data? Training data could be many different things. It could be your transactional data from the database. It could be data from the client software, like ClickLog, basically the sequences going to the web server. It could be application data. It could be something you are putting into an internal application behavior log. Anything can be training data. As long as there is a pattern in it, we can mine it. And it can be of any form. It could be text. It could be free text. It doesn't have to be discrete or continuous data, in fact. All right, so we have a model. What do we do now? Now that we have the model, we cross over to using it in your application. With that model loaded, by the way, models are tiny. Models are very, very small entities. The data at first could have been billions of records. The model could be just a few kilobytes. So with the model in mind and new data that you will use to predict the outcome, you use, again, the data mining engine, which combines those two and performs a prediction. That prediction contains, for example, a new column which contains the predicted success or failure of this transaction, or it predicts new data, such as how much will this customer buy from us in the future? Will this customer be a good one or a bad one for us? There are no bad customers, of course. There are only the ones who don't spend enough. That new predicted data is the goal of the process. So what can be the data to predict, you may ask now? Data to predict, again, could be the same data that you were using earlier, plus that most exciting case for us now, the just one row of data. Basically, the screen that the data clerk is entering, the transaction that you are about to process. It could be a case in question. We call it a singleton. The singleton, that just one row of data, is what an intelligent application most often will use. That's it. That's the data mining process. Not difficult at all. Architecture in terms of software that you need consists of SQL Server's Analysis Services Server, which comes in every edition of SQL Server except for Express Edition. So no, you don't need to have Enterprise Edition for that. In fact, all of you have it if you have the Developer Edition already. And it hosts the various data mining algorithms. You will use the Business Intelligence Development Studio. Don't worry, this is not a new tool. This is basically Visual Studio with a few add-ons. But if you don't want to, you don't have to. You could write everything as your normal code in C# or whatever is your favorite language. In fact, in my demo, I will not even show you the BI Development Studio. I'll do everything in bog standard Visual Studio, which, by the way, could be pretty much any edition, 2003, 2005, 2008, whatever you want to use. So by means of your chosen environment, you deploy a mining model to the server. So the server hosts the model. Now, the data source provides data to the algorithm to build the model, as you have seen, or I should say to train the model, as you have seen on my previous slide. You write your own application, which will communicate with the analysis services and your model by means of OLEDB, ADOMD, or XMLA. We'll talk about it later in the session. And of course, this is the point at which the application data will fly into the mining model for the purposes of making predictions, which make your application intelligent. DMX, or data mining extensions, are the most important language for you to learn, and the simplest. If you are casually even looking now at the slide, you are realizing that DMX looks almost just like standard SQL select language, right? It's nothing special. It's very much like transactional SQL that you are used to. And even if you don't do database stuff, it's tremendously easy to learn. The three examples, which I will discuss in detail a little later, show you how to create a mining model, how to train it by inserting into it training data that will discover the patterns, and at the bottom of the slide, you make a prediction by means of a select statement, which is known as a prediction join. So what are the steps by means of which you will now build your application? Now that you understand the technology and the process, we start by preparing the database for mining. You ensure it's good. You ensure the data makes sense. Not difficult, but you have to do it. 2, you create and train your data mining model on your data, which consists both of inputs and actual outcomes. So that's why we typically look at a transactional data, that transactional log that consists not just of information about just ordered goods, but the full loop needs to be closed. Goods that were ordered a while ago, and have they successfully been delivered or not? Perhaps services that were ordered, and have we had complaints about them? So it's not always the freshest data you will look at. It takes a little bit of time. Then you test the model. You must test the model. It's easy to build a model that predicts nonsense. So you normally simply take your training data and reserve like 20% of it. And you say, okay, this 80% I use for training. This 20% I use for testing. Very simple. You feed the data into the model, and if it predicts what's already in the data, then the test is okay. Very simple. Testing is not difficult. It's not like it requires writing something new. Just split the data. And in SQL Server 2008, you don't even need to split it. You just designate the proportions. 4, now the model predicts the outcomes. And 5, your application uses those predictions in an if statement or case or whatever else you use. In other words, the bit that is the most important aspect of your application to use that intelligence is just some kind of an if statement that says, if probability of this case is greater than 50%, then do this. Otherwise, reject it. That if statement is really where the intelligence happens. That's the link between the prediction and what the application will do. And finally, 6, you update and revalidate the model periodically because the data will evolve and change. Behaviors will be modified. What was true in the past will not be true in the future. How often? There's a debate about it. Some people will do it as often as maybe every night, every week, every month. It's typically not done in real time, but I'm sure you could find a case where that would make some sense. Let me introduce a few concepts. They are easy. Case is a set of attributes that you want to analyze. For example, age, gender, and annual spend of a person. The nested case is really like 2 related tables. A person, and in the nested table, or nested case, the things they bought. So, me and the books I bought from Amazon over the last year. That would be a nested case. Case key is a unique identifier of a case. There's also a nested case key, which, as you can guess, is similar. But a key in data mining is not just an identifier, it actually provides useful information. A key is typically something you want to look at. It's not like a primary key. Data mining model is a container for patterns. And it typically consists of a relational table, which internally stores key columns, input columns, and predictable columns. And by the way, you don't need to know about that at all. This is just in case you were interested what they look like inside, and you wanted to analyze those. So what are the steps to build a data mining model then? Well, creation consists of defining the columns. I will show you that in a minute. Model training, you feed lots of data from a real database, and at that point you have a model. 3, you test it. Again, you feed a lot of data from the same or different, carefully built database. If you want to be really proactive in perhaps testing against values that didn't yet take place, and if you get nonsense, you adjust parameters, or you change the data, or you correct your error, or you use a different algorithm. There are 9 algorithms, and they are subtly different. Or you are just unlucky, and this data will not ever predict anything useful, which happens, unfortunately, sometimes. And 4, you use the model to predict the outcomes, and that is the logic of your application, number 4. So let me walk you now through all of those steps by showing you actually the syntax you would use. I'm using DMX here. Create mining model is, of course, the statement, the command that you will use to define your model, and its general structure is here on the slide right now. In a minute, I'll show you how to define the columns, and at the bottom, using algorithms, some parameters, and an optional parameter drill through. Using algorithm is where you select the algorithm that is best suited to your case. Drill through is just an option that will provide the actual data within the model in the resulting table in case you wanted to analyze why a particular pattern is such or different. It's not normally necessary for your applications to use with drill through. All right, so I'm going to create my model using Microsoft Decision Trees. Microsoft Decision Trees is one of the algorithms, and may I say it's probably the most important algorithm for you. Not necessarily for all cases. It is an algorithm which not only finds a pattern, but it also gives you an answer why this pattern is like that. So for example, you can use Microsoft Decision Trees to analyze sales to find out what makes a customer buy, I don't know, a boat from you. And you run sales of everything you sell. So you're a big shop, you sell boats, televisions, books, milk, you sell bicycles. Basically, you're like a Walmart or an Asda of the world, for example, right? So guns, right? So at that point, you've got your data, you feed it through the model, and it tells you that the key reason people buy a boat from you is if they have a bicycle. That's what comes out. So wow, that's amazing. Okay, so let's have a look. What happens? If I have a bicycle, click, I can open it. What are the other parameters? But what about the ones who don't have a bicycle? Do they buy from me a boat too? Of course they do. So what is the thing that makes them buy? And it turns out you click, those who don't have a bike buy from you, provided you didn't sell them a gun in the past. That could be realistic data that comes from your model. And you can keep clicking and clicking and clicking through the model to find out a whole decision structure that leads to a successful sale. That's why it's called decision trees, because it's a tree that tells you how you reach a decision. But you don't need to look into the detail of it. You can just completely ignore it and just say, I'm simply interested in knowing what makes a customer tick. Okay, in our case, we use Microsoft Decision Trees, and I'm going to define a few columns. The first one will be a customer ID column. So there are 3 things here that you see: cust ID, text, and key. The cust ID is the name of the column. The text is the data type, and there are many different data types you can specify here, such as text, long, double, boolean, and date, and a few additional in 2008. And finally, key is a content type. Key can be something different. It could be also discrete, continuous, or discretized. Those are very important functions which parameterize the way the algorithm works. It's really easy to understand it. If something is a key, well, that's something you are pretty much looking for. Discrete, continuous, and discretized. Discrete is like gender. Discrete is like for values, for example, for occupation from a fixed list of occupations. Continuous is, for example, income of a customer. And discretized is for a continuous that you want to treat as discrete. For example, you may not be interested in every possible income value. This person earns 17,368 euros and 52 cents. You don't care. Maybe you only care in people who earn 0 to 10, 10 to 50, 50 to 200, and then 200,000 plus. So you could discretize your continuous data into a number of buckets. But wait, you don't have to even discretize it yourself. Just say discretize, and it will know how to discretize it for you best by looking at the statistical distribution and, for example, the bell curve. You don't need to think about it too much. But if you do, of course, you can manipulate it. So discretize is really great for simplifying complex data into simpler data without having to do much about it. All right? So we have our first column defined. We are going to define gender, which, of course, is textual. By the way, if it's a Boolean, fine, you can say it's a Boolean, but in most cases, it doesn't matter that much to the data mining model. It's not like writing software where, of course, you have great benefits from using a very specific defined type. In our case, it's discrete. Actually, by saying it's not a Boolean, you do cover for additional cases where there are, of course, more than two possibilities for this value of this field in the case you wish to track it. I guess it should be even continuous if you really want it to be fully politically correct. Marital status, that one will be typically discrete. Education, in our case, education will be discrete. Are they a homeowner? Notice, not only it is a text discrete, but you see a new parameter, predict. That is the value we will be looking for. We denote the usage of the field, and the column can be used in several ways. It could be predict, predict only, or nothing. If it's nothing, it's an input. You will analyze it. If it's predict, you will both analyze it and predict it. If it's predict only, you will not analyze it, you will only predict it. In case you are getting tired now, predict is the most frequently used version here. Predict only, although may sound sensible, actually is used not so often. Age, we add income. Income is double continuous in our case. And, and that's for the time being enough. But as you can see, I left a little bit of an empty area here because right now into this, I will stick a nested table which represents the purchases this customer made in the past from us. So for example, this could be a nested table. As you can see, we have different customers with gender, marital status, education, and home ownership values, and they bought different things. So for example, we learned that customer ID 98003, who is a female, single, at the level of Masters of Education, owns a house, buys from us a Lazy Girl recliner. Those are huge amounts of data coming perhaps from your data warehouse. What I need to make you understand here is that unlike in strict relational database world, a nested case is a bit of a dirty creation because it's really hierarchical. A nested case is a table in a table, or table in a row even, if you want to say it that way. Is that a problem? No, we really don't mind. If you want to treat it as a related table to another related table, you can, but that will be inefficient because the data mining model will have to do an awful lot of pivoting in order to treat all of the data as a pure third natural form relational structure. So actually this dirty little trick of sticking hierarchical data into the table makes the algorithm more efficient. And we don't need to change the APIs much, because ADO and all of the other famous ways of accessing databases support hierarchical data. Nested cases, therefore, are natural to express and transmit between your software and this analysis server. All right, so in terms of code, what you need to do is you simply say table. In this case, column called products is really not a column, but a nested table. And in our case, that nested table consists of just one column, which is the product they bought, which, as you can see, is a text and a key. That key is known as a nested key, and it is a very important key because that is probably what you will be predicting later. In our case, no. In our case, the model I am building is not for predicting the sales of new products, but it is for predicting, as you can see where the word predict is, whether they are going to be a homeowner or not. But if you wanted to instead predict on the basis of the data what they will buy from you, you can stick predict here or here. Wherever you put predict, that's what it will predict. All right, we created a nested mining model. Now we are going to train it. Training the model uses standard SQL insert statement in order to shove lots of training data into your model. For the example of code, this is the syntax you would use. Insert into, instead of naming the table, you say mining model, mining structure, you give it the name, and you list the columns and the source where the data comes from. You can source the data from another query, which could be another data mining query using DMX, MDX, which is of course multi-dimensional query, so that's OLAP structure. It could be a stored procedure call, or it could be a row set parameter. In fact, you could even manually insert data if you wanted to, but that of course wouldn't make much sense when you are training it. Remember, at this stage, we are still building the model. If you already had a model from someone else, or one you built yesterday, you don't need to do this, you don't do the insert into, instead you would import the other model, for example, by means of PMML, which is that standard for exchanging models between different analysis providers. So we've trained the data, and we come to that most important point in your application, that is making the prediction, for which purpose we simply use SQL select semantics with a new type of a join known as a prediction join. What will be returned? As a result of that, there will be a table. It can be just one row. It could be the first 5 if you want, or it could be all of them. That will contain predicted values based, of course, on the model and the data you have inserted into it. This is where the magic happens. This is where you are applying that tremendous power of the algorithm to discover future. And to show you the syntax, select top if you want just a few records. Expression list contains possibly functions which the algorithm may support, such as functions for predicting the probability of a case, or functions to predict the variance of age distribution, if you really want to play with the statistics, which you don't have to. Then you say prediction join, and then you do one thing or the other. Either you have on, and you do column mappings. In other words, you basically say which column in your data source should be mapped to a column in your model, or if the column names are identical, you use the shortcut and you say natural. Natural prediction join simply assumes that the names of columns in the model are the same as the names of columns in the source of the data. It's just a nice shortcut, and one you will no doubt use when you play with this later. So that's pretty much how you work with it. So let's talk about the APIs which will connect your application to it. That is up to you to choose. There are many APIs. Of course, you probably all want to go straight for ADO.NET, and there is nothing wrong with it. It works perfectly well. But if you still have all the software, maybe even compiled before the age of .NET frameworks, and you want to use only DB, no problem. ADO.MD.NET is known as ADO multidimensional for .NET. It gives you ability to further drill the structure of the model. I'm not going to talk about it. Analysis Management Objects, or AMO, is really not for dealing with the data, but for working with the configuration of the model itself, modifying it, etc. It replaces an older API known as DSO. DSO was introduced in SQL Server 2000, which indeed had some forms of data mining, but it was quite limited. And of course, the two perhaps languages, but they are in fact APIs that you already know, DMX, which we have seen, and XMLA, or XML for analysis, if you wish to use that. Those APIs communicate with the analysis server in different ways. Most of them can communicate either by effectively sending XMLA over TCP/IP or directly. XMLA over TCP/IP is actually the typical data or protocol standard that will be used between all of the different APIs and the server if you wish, if you don't go for any form of raw transport. So on top of it all, you can have your application using your favorite database mechanism. At the bottom of it, analysis server will happily communicate with OLAP and the data mining engine, which is the one we are talking about all the time. Further down, the data mining engine can communicate with the built-in Microsoft algorithms, or if you are interested in it, you can even supply your own algorithms to it too. By means of the data mining interfaces, which are of course published, you can connect your own different algorithm, one you've been perhaps researching, and compare it with how it works, well, better or worse than the Microsoft one, as an example of a project if you would like to do. So what's the intelligent bit in your application? Now that you know how to build it, how to work with it, you know about the APIs, the last step is your application. That's just the if statement. If, okay, select whatever it is. Basically, in your code, in your application, you build a case, a set of attributes representing the case in question. For example, a shopping basket of a customer plus their shipping information. 2, you execute the prediction join. So you select, here goes the singleton that you built in step 1, prediction join on the already loaded data mining model. 3, you parse the returned data. So you parse the attributes, and the most important one you need to parse is called the probability of the outcome of this case. In other words, the case probability. That case probability now has to be over a certain threshold that you design for the transaction to be accepted or rejected. So for example, you could say 50% is enough for me. Or maybe you want more certainty. Maybe you want to ensure that the probability has to be as high as 70% for success in order to ship it without flagging a concern to the manager. Nothing should prevent you from making that percentage variable. Imagine you are a bank. Of course, banks use data mining a lot. For example, they use data mining for credit assessment. And do you think that banks accept and reject customers every day with the same threshold? No. If the business is good, the threshold is dropped. If the business is bad, well, they become a little bit looser, and they keep increasing it. So you could actually make the threshold a variable. In fact, you could make the threshold a variable which is the output of another mining model which predicts your sales based on that threshold. And then what do? You just go where you sit, and the business takes care of itself while you have fun in Hawaii. 4, that's that intelligence. That's where your application has made a decision. That's it. The magic happened. That if statement that compared the probabilities where you made your application intelligent. 5, refresh and retest. Daily, nightly, every week, I don't know. But you need to refresh and retest. Not just refresh, but also retest. And quickly you will know whether your mining model diverges. Maybe your mining model will need to be rethought through. In the worst possible case, you had a tested model that worked, which actually was wrong. Hopefully you would have noticed that soon. So, you've waited patiently, and in the last 25 minutes of my presentation, in the last 23 minutes of my presentation, I'm going to actually demo everything I talked about. Well, not everything, but most important parts of what I have talked about in a short 15-minute example. And then, after the demo, I'll spend about 10 minutes talking about algorithms, and I'll close the session. Righto, so what have I got here? As I said, you can download this example from www.sqlservermining.com. If the site is working, and it was working today, it is available as datavalidation.zip. You have to register to get that, but so far I didn't get any junk yet from the owners of the site. Simple web page, new customer entry. where I'm going to enter the name of a prospective customer and some data such as gender, age, the number of years of education they have, occupation they fulfill, and their relationship to the head of household. This is an insurance application that will help the data entry clerk prevent entering stupid data. Basically, it's a data validator with no rules. All right? I'm going to show you the code in a minute, of course, but before I show you the code, let's build the application, see it working, then we'll look at the code, and then we'll look again at the way it works. So as you can see, it succeeded, which is always a good example. Yeah, we don't care about the warnings. And we are going to start the application. And there it is. As you can see, it's running on my server. I'm running this on Windows Server 2003. You can run it under XP, under Vista. If you run it under Vista, it will work. You just need to tweak the credentials of the user under whose auspices the IIS process starts. Other than that, you can play with it right now. So let's have some fun. First of all, let's see whether a tech ed geek would be able to get driving insurance. So predominantly male. My data tells me on average you are 35 years old, and I guess you've had about 15 years of education. You are typically a professional technical, and you are typically a single head of household male. Right. Will you get insurance or not? Submit. Application accepted. Our model says this is a very classical case. This is normal. All right. Let's see whether a tech-ed geekette would get insurance. She would be on average 32, but with the same amount of education. In our business, being professional, she also happens to be a female head of house. And as you can see, no problem, she also gets the insurance. All right, let's have more fun. Let's say, what about Power Vivian? She is female. She is a young 42 years old with a tremendous 21 years of education. She happens to be a farmer, and she's a female head of house. Whoops. Suspicious data entry in the education field. Modify values or hit accept. In other words, our data mining model says that it is not very likely that we are going to have a 42-year-old female with 21 years of education who happens to be a farming head of the household. Would you like to know why? I just have to click this button to show you. But first, you have to see the code. All right. To make this demo easier, everything is shoved into one file, which makes for very bad programming practice, but a very easy demo to demonstrate. So I have collapsed almost everything here so that you don't have to look at too many things. I'll just scroll to the end, and I will open some of those in a minute to show you what's really important. At the top, there's some housekeeping, which is just weird programming style, just to encode which of the fields were selected by me as I was entering the data. I'm going to be using OLEDB in this case, so you could run this on the oldest version of Visual Studio and SQL Server 2005 if you wanted to. This is where you customize the name of the data mining model, and in terms of both the model you use for prediction and validation, if you wanted to use different ones. And this is the important value. This is the probability of accepting the case. And we say 45% is our cutoff. If it is more unlikely, we will reject it. 45% is a fairly low score. I probably should make it higher, but the insurance business is not doing very well right now, so we'll stick to 45. Page load is boring. There's nothing over here other than changing the color. Everything that this application does is stuffed into what happens when I click on the submit button in here. And I will show you that in a minute. I'm not going to spend too much time showing you what happens in build singleton and build columns, because they are fairly dirty functions that just build a string query depending on which values I selected. I'll flash them, but they're really dirty and there's nothing special about them. Just lots of concatenation of text based on which bits were selected, whether I specified the age or not. So really what I need to show you is button submit.click. So let's open that and just scroll to the top. For some reason it went to the bottom. And let me tell you what happens over there. So we start with an empty query, and we actually build two strings, one which we will send to the data mining analysis server, and the other one which we will display on my form for your enjoyment. Then, of course, we handle the exceptions. Let me just scroll that a little so you can see the full line as much as you can. We create a data mining command, which is just an OLEDB command. We have a reader. We will associate them with each other in a minute. We open the data mining connection. And of course, at this point, we are going to start building the query that we will execute on that connection by means of a reader that I have just declared here that will keep the returned results that I will parse. Parse, not pass, parse. This is a bit of dirty coding in a funny style, which simply builds different parts of the query depending on the column selected. But this pseudocode, which is here in the green as a comment, this one here, is really what I am doing. So what I'm doing is I'm building this select statement, which is the prediction join. You know, it's a natural, you know also that it is a natural prediction join, as you can hear, because I am going to, sorry, I'm using a natural prediction join because the names of the columns in the model are the same as the name of the columns in the data that I will be sending to it. And if you look at the model that I am building, the very first thing I want to build is probability values for the occurrence of the different values of the columns that I enter into the screen you have seen before. But really, the most important one that I will be predicting is this one. Predict case likelihood is one of the DMX functions of the algorithm that I am using in this case, which gives me that magical number that I will use in the if statement in a minute. The rest is just concatenation. And of course, this is pseudocode because this is all done by the two helper functions that I've got at the bottom. There are some columns, so this is now, let's talk about the real code. So there are some columns that I always want to have in my prediction join, like the likelihood of the case. I want to predict the gender, occupation, and the relationship to the head of household. At this moment, I call the build singleton function, which, depending on the values I selected, that silly bit masking technique, builds me the singleton values for the query. A little bit of checking is done here, and this is the point at which I am building the actual query. By using the string.format, I'm using 3 bits of data. The first one, or 0th one, is actually the singleton that I built a minute ago. I'm sorry, that's the last one, of course. The first one is the list of the columns that I wish to predict, the list of columns that I always include, and the values that were simply taken from the input screen. And that forms the select natural prediction join with the values given. All right? What do I do at that point? A little bit of housekeeping where I replace a placeholder model with the actual name of the model, and then I format the same query string for your viewing pleasure, so it will nicely appear on the screen by converting it to HTML with these 3 very simple operations. Not very safe, but who cares, it's just for a demo. That is the most important bit. That's the second most important bit. This is the moment at which I execute my query, which is in the command, on the reader, which is associated with a connection, which is talking to the analysis server, which has an already preloaded data mining model. Did I preload the model in my application? No. That was done by the administrator, or maybe you before, and it just sits there forever and ever, and it lives there. The model is like a data table. It's like a table in a database. You don't actually need to write code for it, which is even better. You could if you wanted to. All right, I executed it, and what do I do now? Now is a mundane and boring part of somewhat inefficiently, for a demo done in 2007, I'm sure you would do it better, parsing the returned data. So I basically will parse it bit by bit in the order that my select statement returns. And what will I parse out? Obviously, the values I'm declaring here: gender, predicted age, variance on the age, occupation, the relationship, and so on. As you can see, the actual parsing is done here simply by getting the values from the reader, and then some more. The most important one that I'm interested in happens to be somewhere in the middle of the returned data set, that one row, the case of the probability, predicted gender, occupation as a string, and as a string, predicted relationship to the to the head of household. So my prediction join not only gives me the probability, but it will also tell me what the model thinks Power Vivian actually does based on the statistics. And that happens here. Then there is a little bit of magic, which honestly you can completely ignore, which simply does a little bit of computation to predict the ratio of the variance. I'm so uninterested in talking about it right now. It's only there for testing the application. So it's left over there in case you want to look at it. But from here, roughly from here, up to the bottom of here, you can totally ignore this stuff. It's irrelevant to how your application works. It's just for the beauty of it. So since it's almost 12:30, well, it's actually 6:33, we're not going to talk about the boring stuff. We'll talk straight away about the exciting stuff, which is here. We are going to, we are going to make our application intelligent. That is the if statement I was talking about throughout the whole presentation. Right here, I'm comparing the computed case from the model, the predicted probability of the case, with my threshold level. And if it is below that threshold level, I'm happy. And if it isn't, I'm simply saying suspicious data entry in there, and here is a string which selects the field depending on which bit offended us most. So for each of the fields, we look at the probability. So we don't know whether it was age, occupation, relationship, or education until we look at the ratio. That's why I had that code just strictly about this line. But you don't have to do it. You can just say reject for no reason and send it to your supervisor to analyze. Naturally, they would prefer to know why, so you can just copy this code and it will tell you why we rejected it. Otherwise, we simply accept the application. Application accepted is the text, and that's it. I am not going to bore you with how I build the singleton. It's just, as you can see, concatenation after concatenation, and how I build the column list, also concatenation after concatenation of the different functions which are being built as a text. That's not the most efficient way to do it, but it's kind of quick and dirty, and it works without having to do too much work preparing your demo at home if you wanted to try it out. Button reset click simply erases the data, and the checkbox show details simply makes visible the entire query plus the results that came back from the predictor from the data mining analysis server. So, was that easy? Yeah, I think it's easy. I know it's late, and I know you've seen probably more lines of code in the last few days, but I think there's nothing really magical here. All right, so let's go back to Power Vivian. We left her hanging there, not knowing if she's going to get an insurance from us or not. And the system said it's suspicious. Her education is wrong, considering her perhaps other values. By clicking on Show Details, I will, of course, now show you the query and those individual probabilities. The query, as you can guess, is just a prediction join, as we built it, with a singleton values provided here at the bottom. But the most interesting stuff is here, the case probabilities. Our system really thinks she's unlikely to get the insurance. The probability is only 3%. Why? Well, first of all, it predicts that for this case, she would have to have 50 years of age, 58 years of age, or her education should be 12 years, or she should be a professional, or she should be at least a spouse, not a female head of household. The system is sexist, basically. All right, so where did I make a mistake? The mistake I really made is that she cannot be a farmer. The probability with her being a farmer is just so many zeros over here with that amount of education. Of course, I just selected the wrong box. In fact, she is a professional or technical person, and that makes her application go through. All right, let's try some more. How about Jim? Jim happens to be a male. He happens to be, let's say, a 72-year-old male who has 12 years of education and who is a professional and a head of household. Occupation is the problem. The system says unlikely. All right, let's have a look why. Not as bad as with Vivian. 35% of probability. So actually, we could say it's okay, unlike Vivian, which was like 3%. And it basically tells us that the problem is here. The problem is occupation. The problem is that with the data we entered, he really should be retired or not seeking employment. So now our system is not only sexist, it's also ageist. All right, let's try something simpler. How about Joan, who's a female, and Joan happens to be 21 years old, 21 years old, with 6 years of education. She's a farmer, and she is the son of the head of household. Accept? The problem is relationship to the head of household, all right? Naturally, she cannot be a son if she's a female, or can she? Actually, she can. The system says she could be a son with a probability of 0.003%. That's computers for you. All right, so let's change her to a daughter. Let's see if that works. No. It says now we have a problem with occupation. 21 years of age with 6 years of education just doesn't work. She should be not seeking employment as the occupation rather than a farmer. She's either too young or she's got too much education. All right, so she's not seeking employment and she gets her insurance. How politically incorrect was my demo? I hope you'll have fun playing with other values at home. I must admit that this does not represent my views, the views of the organizer of this conference, or the views of my company. The very last thing I want to talk to you about in what is 6 minutes of that's remaining in this presentation is just a couple of words about the algorithms. To those of you who were here at the beginning, yes, I wanted to have a session for 75 minutes about nothing else but algorithms, but the organizer said no. So if you think I should, do let me know when you fill in your evaluations. Do put like more on algorithms, and next year I'll do 75 minutes or even twice that amount of time on nothing else but algorithms and differences. Anyway, Microsoft data mining algorithms are designed for fairly open use for most cases. They tend to work for everything. So you have the harder choice of knowing which one to use and when. Their API is identical no matter which algorithm you use. So the DMX is the same. The differences are in parametrization. And by the way, that's the thing you need to get better at as you are working more and more with data mining, is parametrization of your favorite algorithm. So what are they? Here it is. As I mentioned, Microsoft provides us with 9 algorithms. The king of them all, I think, is the decision trees, and I already explained it to you. Association rules, which is an algorithm for finding out relationships between elements. For example, in a shopping basket, people who buy milk buy cheese. People who buy meat buy vinegar, that kind of stuff. Naive Bayes, which is one of the granddaddies of all predictive statistics. It is an algorithm for showing relationship between values of a variable. Sequence clustering, I love that algorithm. This is for clicks on a weblog. If they click on this and that, what will they click on next? This is really cool to find out, for example, why your web pages are not being viewed. You have like super wonderful page, and you want to find out why people are not clicking to it. So it will actually show you the patterns that don't lead to it, or patterns that lead to it. You make one change in an unusual place, and suddenly the page is being viewed. Time series. This is like serious prediction of numerical values. Time series predicts very hard way, very particularly complicated perhaps way, what will be the future value or present or past value if you're missing a value of a numerical, typically continuous dimension, not just on the basis of one number, but a whole, perhaps nested table of those. Neural nets, magic. They're great at predicting things no one notices. Neural networks notice patterns no one else knows exist. I have used the neural net algorithm to do security analysis, and it is really amazing. You basically feed like a log from a proxy, you neural net it, and it suddenly shows you those few things everybody was not looking at. By the way, it's not the best algorithm. Sometimes it finds strange things. So don't put it in an automated application yet. Have a human being check what it predicts. But it's great at warning you that an attack might be happening. Text mining, you can understand. It's like build your own mini Google. Linear regressions and logistic regressions are primarily for determining the relationships to predict an outcome, either in terms of values which perhaps are numerical, or in terms of sequences of operations of occurrences. So which one should you use for which purpose? Well, I've got a matrix here that will help you decide. If you, for example, want to classify your customers into groups, use clustering. That's like the best. Or maybe use some of the others too. All right, what about if I want to find what sells with what? In other words, why do I sell a lot of milk but not enough cheese? Well, that's where clustering algorithm will help you, but the others will also help you a little bit. Or what should I be using neural networks algorithm for? Well, that one is natural for classification of users, events, or customers, for estimation as well as text analysis, but it's really best application perhaps comes in exploration of unknown data. It's a great algorithm just to be data mining live with. I so wish I had now another session just on those and show you parameters, but unfortunately I'm going to have to leave at this point and send you to a place where you can learn more. SQLServerDataMining.com is where you can get the sample and lots of other stuff. There's a lovely book by Jamie McLennan and Xiaohu Tang on data mining with SQL Server 2005, available from Wiley. There's a lovely on-demand webcast. You need to enter event ID, which is specified here, called Intelligent Applications Embedding Data Mining in Your Application. But of course, you can just watch the recording of this session again and again and again if you need to get into depth. And there are a few other blogs. My definitely great friend, mentor, and perhaps idol of data mining, Mr. Donald Farmer, Jamie McLennan himself, and there are two kind of more impersonal blogs and a forum which is quite active. If you have a problem with a demo, for example, go to that forum. That question probably has been already asked before. SQL Server books online also are a good place for you to find out a little bit more about the parameters and the values. Of course, if you use SQL Server, you know about SQL books online. In summary, I hope I managed to show you that data mining is really powerful and it's really underused. What is really unique is how it works for developers, especially the Microsoft version of it. Simply, it turns information into knowledge you can act upon. Both 2005 and 2008 versions of SQL Server analysis services are there and free of charge, as long as it's not an express edition. They've been designed to help you, the developer, build intelligent applications. So here's my call to you. Build an intelligent application, and let's start discovering where it's going to lead us, because I feel that we haven't even scratched the surface of where this technology can take us. And I tell you, in 10 years, you'll be all happier and probably in Hawaii by now, and probably not working more than 2 days in a week if you use this technology, right? With a certain probability of the case, yes. If you would be so kind, please do fill in the evaluations. Any comments you enter, I will definitely read and act upon. And all that remains for me to do at this stage is to really thank you very much for your kind attention, and I wish you all the best of luck. Thank you.